So quantum mechanics is a model, a theory, and it explains observed behaviors. We've learned that the behavior of elements, their chemical properties, have a periodic nature in the table. And Mendeleev observed that, and he ordered them and lined them all up, but didn't understand why. Now we understand why. And the reason is the number of valence electrons is periodic. So elements in the same column have the same similar properties. They also have the same number of valence electrons. And it's the number of valence electrons that causes those properties to be so similar. Valence electrons are periodic because the types of orbitals that they occupy are also periodic. So if we look at the noble gases, that far right column, these have 8 valence electrons. They're in group 8A. The exception, of course, being the little He-Man. He's got 2. But that is a full valence shell. Okay? He's only got 2 electrons in the 1s, but the 1s is full. So he's too small to have 8. But these all have a full valence shell. These are especially non-reactive. In fact, for a long time it was believed that they made no compounds at all. And still, I believe there's no known compounds with helium, and very few with the others. They don't react. They just don't. That's why they're called noble gases. And the reason they don't is that 8 valence electrons is especially stable. When that quantum level is full, the energy of the electrons and thus of the atom is lowered. And so they don't need to react. The alkali metals are, they don't look like they're next to the noble gases, but you can think of this periodic table as really just being a spiral, right? You could fold it around and just continue the atomic numbers. These elements are very close to the electron configuration of the noble gases. They all have one more electron. So I think of the noble gases as being like the really cool kids in high school, that in-clique that lots of people were trying to be like, right? They just don't have any time for anybody else. So these guys are so close to being in that group. They just got this one pesky extra electron. And so they readily lose one electron because then their electron configuration is the same as the nearest noble gas. So I think of the electrons as being like the clothes, the hairstyle, the appearance of the atom, right? It's on the outside. What's inside is the nucleus. That's your soul, your personality, who you are as a person, right? You can change your clothes, you can change your hairstyle, you can do all kinds of stuff. But you can't change who you are, right? So these elements will lose one electron. That's like changing your sweatshirt to the right brand of sweatshirt or something so that you look like the cool kids. Does it change who you are? No, it doesn't. But you look like one of those on the outside. So they tend to form +1 electrons, +1 ions, and they're losing that s electron that causes them to be different. The number of protons doesn't change, but the number of electrons does, and now they're ions. So these are very reactive because they very readily react to form the ion. Does that make sense? They're trying to be like the noble gases. The halogens are next to the noble gases on the other side. These have one fewer electron than the nearest noble gas. They're also trying to get that 8 valence electrons to have the same electron configuration as the noble gases. And in order to do that, they need to gain 1 electron. That's not so hard to do, and so they tend to be quite reactive, and they will react to form a -1 ion by gaining 1 electron. We learned to predict charges of lots of the ions based on their position in the periodic table, and the quantum mechanics explains why that is. We just looked at group 1A and group 7A. Group 1A loses one electron because then the electron configuration is the same as the nearest noble gas. Group 7A gains one electron because that also makes their electron configuration the same as the noble gas. Group 2A has 2 electrons to lose. And group 6A needs to gain 2 electrons. And so all of those predictable main group elements are gaining or losing electrons to have the same number of valence electrons as the nearest noble gas. So here we've got the noble gases over here with 8 valence electrons. Here's fluorine, chlorine, bromine, iodine. If iodine gains 1 electron to become this I- ion, it'll have the same number of electrons as xenon. And this chart in your book, they numbered the periods wrong because hydrogen is left off, and that's number 1. Good grief! I was hoping they'd fix that on the most recent edition, but not so much. Let's look at the electron configuration for sodium. So we could write sodium as being neon 3s1, right? If we lose 1 electron, becomes Na plus. Now we've just got neon. If we look at fluorine, there's not really any point in sticking helium in there. 1s2, 2s2, 2p5. Fluoride has 1 extra electron. So when we're doing electron configurations of ions, start with the atom and then either add electrons for the negative ion or remove electrons for the positive ion. So we have to add 1 electron to this, so it'll be added in here, 1s2, 2s2, 2p6, which is the same as neon. We look at the number of valence electrons, 2 plus 6, 8. So 8's kind of a magic number. Any questions? Kind of went over this already. Anions are formed when a nonmetal gains enough electrons to have 8 valence electrons. So you get the s and p orbitals in that valence shell being full. Example is sulfur. Here's the electron configuration for sulfur. We see that it has 2 plus 4, 6 valence electrons. We learned to predict that sulfur forms a 2- ion, so we have to add 2 electrons to it. So they're going to go into this unfilled 3p sublevel to give us 3p6. So this is the electron configuration for sulfide ion, and that's the same electron configuration as argon. Sulfur doesn't turn into argon. It just has the same electron structure. Sulfur is different. Sulfide ion is different from argon, the atom, because of the number of protons in the nucleus. That doesn't change. Any questions? Cations are formed when a metal atom loses all of its valence electrons. So you lose all the valence electrons, what's underneath? A completely full level, right? That process is always endothermic. In order for those electrons to be removed, it requires energy. Now we said they're very, the group 1 is very reactive because it likes to lose an electron. It does like to do that. It does it very easily, but those electrons don't just fall off. You do have to pull them off. It's just that it doesn't take much energy to do that. Magnesium atom has this electron configuration. It's got these 2 valence electrons here. By forming a 2+ cation, removing those, now it's got the same electron configuration as neon. So the quantum mechanical model explains why the atoms take on the charges that they do.